Today's lesson we're going to learn about calculating density for gases. So there's two ways to do it. One is the easy, quick way, which is if it's at standard temperature and pressure, which is 1 atmosphere, 273 Kelvin. Since 1 mole of any gas occupies 22.4 liters at STP, and 1 mole of anything is going to weigh its molar mass in grams, we can simplify the density equation, which is grams per liter, to the molar mass divided by 22.4. And that's because molar mass is grams per mole, and molar volume would be liters per mole, and the moles would cancel out, and you'd have the molar mass divided by 22.4 liters. So all we would have to do if we were calculating the density for, say, methane at STP is divide the molar mass, which is 16, by 22.4, and we'd see that the density of methane is 0.71 grams per liter. The other way, which is if it's not at STP, is you have to use the ideal gas law. So basically what you have to do is find the number of moles of the substance, and if you do that, you can figure out how many grams it is. That would plug in the numerator of this, and we can simply assume 1 liter if we're finding the density, because if we know the number of grams in 1 liter, we know the grams per liter. So the problem I'm going to have you do right here is determine the density of O3, or ozone, at conditions of 2 atmosphere and 400 Kelvin. So again, we rearrange the ideal gas equation to solve for moles. We plug in our values: 2 atmospheres for the pressure, 1 liter for the volume, 400 for the Kelvin temperature, and we use the gas constant that's applicable to atmospheres. And then when we solve for moles, we get 0.061 moles, and when we multiply that by the molar mass of ozone, which is 48 grams per mole, we get that we have 2.92 grams of ozone, and that was in 1 liter, so our density is 2.92 grams per 1 liter.